Chair, Christophe Biskup, through an online connection. Christophe, are you there?
Yes, I'm here. Good morning.
Hey, Christophe, good morning.
Can you hear me?
Yes, I can hear you. How are you? You are already in Brussels, I think, or not?
Yes, indeed, I'm already in Brussels, and as you can imagine, I already even checked the fire safety of the hotel, and it looks good. The sun is shining, so we are ready to push the button.
Okay, really good. Okay, so Christophe, officially, can you open the European Fire Safety Week for us?
Yes, of course. Thank you very much, Lieuwe, for this introduction. Good morning again. I have a great pleasure to welcome all of you to the European Fire Safety Week 2022. It's already the fourth time we meet at this leading European fire safety initiative. Let me remind you that the first European Fire Safety Week was organized in 2019 to draw attention to fire safety problems in Europe. We invited a number of experts for sharing their knowledge to get a better picture of what needs to be done to improve fire safety of people in Europe. This first edition of the European Fire Safety Week resulted with development of the European Fire Safety Action Plan, which is the first evidence and knowledge-based fire safety agenda for Europe. In this action plan, together with over 300 experts, we defined the biggest fire safety problems and challenges in Europe, and we proposed also actions on how to solve them. This year's edition, together with our partner, we have prepared many interesting initiatives having the common goal of improving fire safety across the European Union and better contribute to the implementation of the European Fire Safety Action Plan. And so, today we start with the webinar on fire safety of vulnerable people in Europe. Also today, but afternoon, you are invited for the carbon monoxide roundtable, which will focus on the link between growing energy poverty, carbon monoxide, and gas safety. It's a very serious and topical problem due to energy crisis we face with in Europe. Tomorrow morning, we start with a high-level political discussion in the European Parliament in Brussels with the key policy makers. This discussion is aimed at consolidation of political support to fire safety considerations into the renovation wave. The high-level discussion is the prelude to a stakeholder workshop we organized the day after, also in Brussels, to elaborate on practical implementation of this fire safety provision by member states. These both events are organized under the same title, Putting Fire Safety at the Heart of the Renovation Wave. Also tomorrow, but afternoon, we proposed a webinar on harmonization of European fire statistics. Participants will get a presentation of the final report of a very important European project, EU FireStat. They will also get explanation on outcomes of the EU FireStat project, and we are going to discuss also proposals for its follow-up. For Tuesday, next two webinars are proposed. In the morning, on the product compliance with fire safety requirements, titled Enforcing Fire Safety Requirements in Europe, How to Ensure Stricter Compliance. And afternoon, the expert will look at what can be done today and what more needs to be considered with respect to achieving higher and more harmonized level of fire safety in the European Union, during a webinar on recognizing fire safety in revised EU legislation. On Friday, we start a first edition of the European Smoke Alarm Day. It will be an awareness campaign, Smoke Alarms Save Lives, consisting of a new dedicated website and a social media campaign. In this campaign, among others, we will use the video messages of support from firefighters across Europe to inspire fire personnel and citizens to participate in this campaign and to install smoke alarms, of course. European Fire Safety Week has been and continues to be supported by many experts in institutions, including members of European Parliament and European Commission officials. And this year is no different. So I declare the European Fire Safety Week 2022 open, and I wish all participants interesting and fruitful week, and I encourage you to support our efforts to make Europe fire safer for all inhabitants. Thank you very much. Lieve, I'm coming back to you.
Thank you, Christoph. Thank you for these nice words, and we are going to have a really good program, I think. Also to an online connection, we have Stefan Wevers, who is president of the Federation of European Fire Officers. Stefan, are you there?
Yes, good morning. Good morning, Lieuwe. Good morning, Christoph.
Hey.
And good morning to all of you.
Hello. Good morning. I think you're in the Netherlands. You're in the beautiful region Twente, I think, or not?
Yeah, that's correct. That's
yes,
correct.
Okay. Okay, Stefan, can you give us your support for the European Fire Safety Week?
Yes, I can. No problem, Lieuwe. Well, as I said, good morning to all of you. And let me first introduce myself a little bit. I'm Stefan Wevers. I'm past president of the Dutch Council of Fire Chiefs. And since 2020, I'm president of the FEU, the Federation of European Fire Chiefs Officers. And as a FEU president, I'm also in the core group of the European Fire Safety Alliance, because it fits exactly into the vision of the FEU. It fits exactly into the three main programs we run as FEU. Exchange of knowledge and experts. Secondly, the leadership. And third, the professional voice of the fire service in Europe. So it fits exactly. And of course, we have been a partner with the FESU, of European Fire Safety Alliance, since its inception, because the objective is important for safety in Europe. It's about saving lives. And we can greatly reduce domestic fires death through education, cooperation, and to put this issue on the European and national agendas. And this year, the theme of the week is the energy transition. And it's a topic that deserves attention because it will significantly affect our future as firefighters. It's one of the main topics of the United Nations Sustainability Development Goals, and we need to prepare for this one. Safety regarding the energy transition should not be the final word in European policy. We need to make our voice heard at that front as well, as FEU and as European Fire Safety Alliance. I'm also very happy that we are working on European fire data. Christoph told something about it. We as FEU are also partners in this project, and we need FEU data to support our story, but also to compare the data of countries in order to learn from each other. What does work and what can we learn from other countries to reduce the number of 5,000 deaths in domestic fires each year? Finally, I would also like to mention the European Smoke Alarm Day, this Friday, the 18th of November. Let's all call attention to this as much as possible through all social media channels. Smoke alarms save lives, and it should be compulsory in all the EU countries, just like in my own country. And let's support this message, because it's important, and for a very few euros we can save a lot of lives with smoke detectors. So I hope that some MEPs are watching and listening today, because this can be arranged at EU level, and it's actually a no-brainer. Finally, I wish us all an educational European Fire Safety Week, and thanks to Christoph for organizing this as chair of the European Fire Safety Alliance, and thanks to the Dutch Barn Foundation to support this. As FEU, we are fully committed to European Fire Safety Alliance and our good work to save human life, because that's what we are all doing it for. The game is about saving lives. Have a good week, and the floor is yours, Lieuwe.
Thank you, Stefan, and thank you for these good words and encouragement. Okay, let's go back to the program of the webinar. Nowadays, there are several developments, such as climate change and the energy crisis and energy transition, what Christoph and Stefan already talked about. And those developments put pressure on vulnerable people. These crises create problems for existing groups of vulnerable people, but also create new groups, such as groups who suffer from energy poverty. These developments not only have consequences on a socio-economic front, but also have consequences for fire safety. And in this webinar, we're going to focus on the latest research from Belgium and the Netherlands on the fire safety of vulnerable people. So let's go to the program. You see here the program, we have 3 speakers today. The first is Pieter Poppe, who is going to give a presentation about the impact of smoke control on evacuation safety. Then we have Ruud van Liempd, who is going to talk about the reliability of an escape or stay-in-place concept. And last, we have Margo Karemaker, who is going to give a presentation about human behavior in an escape or stay-in-place concept. We have those 3 speakers after each other, and afterwards we have a roundtable discussion. So if you have any questions regarding the presentations or regarding the topics, please put your questions in the chat function, and we can bring them in through the roundtable discussion. Okay, and then the webinar will close around 12:30. So let me go to the first speaker, Pieter Poppe. Pieter Poppe is head of the department consultancy at ISIB, which is the Institute for Fire Safety in Belgium. Besides being a consultant, he is also active in several European standard committees concerning fire safety in buildings. And he is also the project manager of 2 VIPA studies where the fire safety of residential care buildings was examined. And he is going to give a presentation about a big part of those studies today. Welcome, Pieter.
Thank you.
Hey, Pieter.
Hello.
How are you?
Good, thank you.
You're already here in the Netherlands?
Yes, yes.
Really good that you came to Arnhem for this. So,
no problem.
Do you have a good trip?
Yes, I went by train, so it's always relaxing if you go somewhere by train.
Yes, yes. Okay, Pieter. Again, welcome and good luck with your presentation.
Thank you.
The floor is yours.
Thank you. Good morning and welcome to the first session of today, which will handle the impact of smoke control on the evacuation safety in residential care buildings. You see in between brackets the VIPA studies, but the link between smoke control and the VIPA studies will be explained later more. During my presentation, of course, I will give you a short introduction. I will highlight the VIPA studies. I will explain a little bit more on exposure to smoke, also on smoke control, and of course, at the end, I will have some conclusions of my presentation. So, if we are talking about residential care buildings, we see that the occupants of these buildings are often non-self-reliant and also elderly people. They are not only there during the day, but they can also be there during the night. What is also important to know is that they need care during their presence there. And for that, there's a lot of staff in the buildings. So the staff there is not only responsible for the care, but also for the safety of the occupants. And they are trained to assist in case of fire. Important to mention that they are limited in number. If we look at a typical layout of a residential care building, we see that the height of the compartment is around maximum 3 meters. And if you have a common area, it's separated from the evacuation route. However, there's a new trend where the common area is integrated in the evacuation route, as you can see in the figure at the right. The VIPA studies, of course, these studies were performed in assignment of VIPA. And what is VIPA? VIPA is a part of the department VVG. I will translate that in English, and this is Department Well-being, Public Health and Family of the Flemish government. So the studies were performed in assignment of the Flemish government. For, besides national building fire safety regulations, there in Flanders are a specific regulation for homes for the elderly. And although there are no specific requirements to prevent the spread of smoke, there is something, requirement in the legislation that says that the doors of the occupants must be self-closing in case of fire. This is a specific requirement in the Flemish regulation. And the purpose of that is to prevent smoke spread from the occupant room to the evacuation room. The focus in that regulation is on horizontal evacuation, meaning that you can apply subcompartments per building layer in order to move the people. However, if you cannot if the requirements of the regulations cannot be met, that means that you derogate from the regulation, you have to have compensating fire safety measures in order to obtain the same fire safety level. And these fire safety measures, these derogations, are treated by the Technical Commission of the Fire Safety of the department. So that brings us to the object of the VIPA studies. As you can see on screen, we have here a common area that is integrated in the evacuation route. You see in the green lines that the occupant stays in his room. If he wants to evacuate or just to circulate, he can follow the green lines to the exit. So there's no problem. However, because of the common area has a lot of combustible materials, that means that in case of fire, the person will not be able to make the evacuation anymore, because in the common area, which is also the evacuation route, there's a fire, there's smoke, so he cannot evacuate. In order to resolve this problem, there are two solutions. First one is that you make a compartment of the common area. That means you have a fire load there, you make a fire compartment. That means that you respect the regulations. At that moment, it's okay. But as we have seen in the previous slides, the common area is something they want to obtain, and you have to have compensating fire safety measures. However, the Technical Commission of Fire Safety of the department doesn't know or doesn't have a technical evidence what kind of compensating fire safety measures can be applied in order to obtain the same safety level. And that's the reason why we did a lot of large-scale fire tests. Here you see a schematic view of one of the tests where a fire screen was used. The next picture is showing you the descent of a smoke layer during a fire. The next picture is the application of a fire screen up to a certain height above the ground, and the purpose of this test was to create a smoke-free evacuation route. This picture gives you an idea of smoke propagation if you have overpressure in a fire room and the difference between a fire-resistant door and a smoke control door. So this is a room where they used a fire-resistant door, and as you can see, a lot of smoke entered that room. We did not only use large-scale fire tests, but we did also a lot of numerous CFD simulations. And CFD simulations are computer simulations. The studies, the VIPA studies, were performed by Warrington Fire Ghent and or the Ghent University. Why I say and or? Because the first VIPA study was done by Warrington Fire Ghent and Ghent University. The second one was only done by Warrington Fire Ghent, and the third one was only done by Ghent University. Interesting to know is that during these studies, there was a steering committee composed of all relevant stakeholders, being healthcare organizations, government, both local and national, also fire brigade, industry, scientific research institutes, and architects. So you see that all the stakeholders were present to guide the study. And at the end of the studies, the 3 studies, they resulted in an assessment framework. An assessment framework where minimum fire safety measures were determined in function of the evacuation strategy. That means that we will talk about evacuation strategies later on, that there are fire safety measures possible, but depending on the evacuation strategy. Let's talk about exposure to smoke, because is exposure to smoke a problem? As we know, it has an influence on evacuation, but is it that harmful? Is it that necessary to have no good evacuation? As you know, there are criteria, for instance, smoke temperature, visibility, toxicity, all these things. If you are below a certain value of that, you're okay to have a safe evacuation. However, these values are applicable for healthy, self-reliant adult people. But what in case of children, of elderly people, or non-self-reliant people? And that's the reason why the steering committee of the VIPA studies has decided that you, as a safety level, you have to limit exposure to smoke during the evacuation. And that means if we have to derive that through two criteria. That means that you have a limited exposure that's only applicable to visible smoke. And the most important thing, I think, is that you cannot have physical contact of the head with the smoke. So you have to create a smoke-free height of at least 2.1 meters. These two criteria are very important for fire safety measures to be applied, because you can verify if these criteria can be met. If we go to smoke propagation, then we know that it's caused simply, that's physics. It's caused by difference in pressure. It goes from a high pressure to a low pressure. And the pressure difference can be influenced by, for instance, building geometry, daily ventilation, or temperature. What's also interesting to know is that once the smoke is outside the fire room, it's very difficult to predict the further smoke propagation, because you have a lot of influence on that smoke propagation. Of course, smoke propagation is only possible from one room to another room. That's obvious, but you have to keep in mind that can be via a door, then you have two separate adjacent rooms, but it can also happen, smoke propagation, via a ventilation duct. That means that the fire room can locate it much, much further away from the other room. If we have a fire in a room, that fire will always create an overpressure. An overpressure because of the increase in temperature. An overpressure is a buildup of an overpressure, sorry. And the magnitude of that overpressure is depending on two things. The airtightness of the room, so the amount of openings in the room, and also the intensity of the room. So the overpressure, this overpressure is very important. If you don't have an overpressure, meaning you have a higher pressure in the fire room compared to the other room, you don't have any smoke propagation. So the higher the overpressure, the more smoke propagation. And it's also very important to know that there's only an increase of pressure, so a buildup of overpressure, as there is an increase of temperature. That means as the fire is growing, you will have an increase of pressure. But as soon as the fire stabilizes or the temperature doesn't rise anymore, then your overpressure will drop immediately. So we know that if you have a difference in pressure, an overpressure, it will always lead to smoke propagation. But the amount of smoke that goes from one room to another, so the volume flow rate, depends on a couple of things. First of all, the intensity of the fire. We see there the couch that was used during the tests, and this is a rather normal but fast-growing fire. And that means that the faster the fire is growing, so the quicker the temperature rises, the quicker the pressure buildup also rises. And that means that the higher pressure peak is also bigger, higher, resulting in a higher volume flow rate, so more smoke propagation. Another thing is the airtightness of the room, like I said. The more airtight, for instance, what is now in passive housing of even so smoke control compartments, if you have lesser openings, make it more airtight, the quicker the pressure buildup will be, and again, the higher the overpressure peak will be, resulting, again, higher volume flow rate. A third one is the volume of the room. The bigger the room, the more oxygen there is, and it means that if the fire has more oxygen, it can last longer, it can grow longer, and the longer it can grow, the longer the overpressure will be there in the room. So that's also nefast, meaning that your volume flow rate lasts longer. So all these things are very important in case of smoke propagation. Now we have set up the fire safety level, the safety level. We know what causes smoke propagation. If we look at the evacuation strategy and function of exposure to smoke, we have a first situation. For instance, if you have the situation here, we have, again, common area. This is the evacuation route, and we know, and there's a fire in a room. The fire and the smoke, and this principle and this example stays in the room. That means there's no smoke, as you can see, in the evacuation route. That means you can go for an immediate, let's say, horizontal evacuation. An immediate evacuation means that as soon as the fire alarm is activated, they can evacuate. But in case of non-self-reliant people, staff is necessary for the evacuation. taking into account that at night the number of staff is very limited, and such an evacuation can take tens of minutes. However, if you see this picture, you must be sure, of course, that the smoke stays out of the evacuation route. If you look at the picture, you see that smoke and fire are remaining in the room, but of course you have to be sure that it stays there during the whole evacuation time. That means you have to do smoke control. If I have a different situation, and here you see that there's a fire in the common area, meaning that you have smoke in the evacuation route, but it's not necessarily that is because of a fire in the evacuation route. Remember the picture we saw in the previous slide. You have a fire in a room. Suppose that the door is completely open, then of course your evacuation route will also be full of smoke. So it's not necessary to have it with a fire in a common area, but it can also result from a fire from a room. But in any way, if you have smoke in the evacuation route, you have a delayed evacuation or a defend in place. I have to say, defend in place is something we use in Belgium. In the Netherlands, they use the same principle, but they call it stay in place. So if you will hear later on in the presentation stay in place, you have to keep in mind it's the same as the defend in place I'm talking about here, because what is defend in place or what is stay in place? You see the person in the room, he stays in his room because he cannot evacuate. Remember that the fire safety or the safety level is do not expose to smoke. He stays in his room and he waits for the staff or the fire brigade to do the evacuation at a later stage. Of course, again, you have to be sure that the smoke stays out of the room, so you have to do smoke control. But suppose this happens and you have a lot of smoke in the evacuation route, even though the person stays in his room and he waits for the fire brigade of the staff to do the evacuation at the later stage, it's not possible to do the evacuation because you can only do the evacuation if the evacuation route is made smoke-free. So as long as there's smoke there, he cannot evacuate. So they must be sure that the smoke is removed from the evacuation route, and that can be done by the fire brigade or by a smoke control system. Again, we see the word smoke control. We have seen the word smoke control a lot during the past slides, and I think the best definition of smoke control, I will read it, is the ability to guarantee the safety level. And the safety level in this case is a limited exposure to smoke, and we can do that by means of active and of passive fire safety measures. When you are talking about active fire safety measures, we are thinking about smoke control system, detection, residential sprinkler system, or fire screen. Passive fire safety measures are, for instance, smoke control door, fire resistant door, or a damper. This is an example of a ventilator. This is an example of a fire screen. This is a residential sprinkler system, and this is a smoke control door. What was also interesting as conclusions from the VIPA studies that has shown that what kind of which fire safety measure is efficient for a given situation or which not. Let me give you an example. You have, in case you have a fire in the evacuation room, and the height, let's say, is approximately 2.5, then we have seen, by means of the large-scale fire test, that a residential sprinkler system can keep the fire under control. It can limit the pressure buildup, but it cannot obtain a smoke-free height in that evacuation route. It cannot remove smoke in the evacuation route, and it cannot prevent smoke propagation to adjacent room. So this system alone will not be sufficient enough for several evacuation strategies. Another example is a smoke and heat exhaust ventilation system, or a CHEF system. Is that applied in an evacuation route in case of a fire? We have seen it can prevent smoke propagation, but it cannot obtain a smoke-free layer height because of the limited height, and it can only remove the smoke if the fire is completely out. So you see that smoke control is a combination of active and/or passive fire safety measures. I will give you some examples of possible combinations that, for instance, in this case, it's for an immediate evacuation. You see at the left side the figure where you have the common area is full of smoke and of fire. You have the room where the occupant is staying. If you want to have an immediate evacuation, it's not possible because it's directly exposed to smoke. There was only one fire safety measure that was possible in order to have an immediate evacuation, and that was to create a smoke-free evacuation route by means of a fire screen and a residential smoke control system, as you can see in the figures at the right. So that means for immediate evacuation, as we have seen, you have to have a smoke-free evacuation route, and the above of the figure above, you see that the smoke screen is up to a certain height above the ground, and the figure below, it's a smoke screen that is completely down. So this is, for instance, an example of how you can do an immediate evacuation. If you are doing a defend-in-place strategy, then the purpose of that is to prevent smoke propagation. And here are a couple of several solutions for that. First of all, by means of two successive doors, closed doors. As you can see in the figure below, left, I mean, if you only have a fire-resistant door, it will not be sufficient. Because, as mentioned before, you can have a big overpressure in the room, and the fire-resistant door will not be sufficient to limit or prevent smoke propagation. However, the test has also shown that if you have two successive closed doors, then the smoke propagation to the room is no problem anymore. Another fire safety measure is by creating an underpressure by means of a smoke control system. Again, we have the left situation. You have an overpressure in your fire room. You want to have an underpressure in that room, because if you have an underpressure, you don't have smoke propagation for the fire room to the other room, so you apply a smoke control system that creates an underpressure and will therefore prevent smoke propagation to the room of the occupant. Last one, defend-in-place strategy and to prevent smoke propagation is to reduce the pressure buildup. Not only reducing the pressure buildup, but also in combination with the smoke control system. I will show you, you have two possibilities. I don't know if it will be visible, but one is you apply an opening in the fire room. As you know, if you have an opening in the fire room, you will reduce the pressure limit and so on, the smoke propagation. But that's not sufficient enough. You also have to apply a smoke control separation. The same thing for a residential sprinkler system. We know it helps keep the fire under control. It reduces the pressure buildup. But again, suppose you have a fire that's more producing smoke than heat, then you can have an overpressure. So you need the extra smoke control separation. As a conclusion of this presentation, we can say that, and this is the safety level in Flanders. I have to keep in mind that the safety level in Flanders is that in order to guarantee a safe evacuation, you have to limit the exposure to smoke in the evacuation route or in the room in case of non-self-reliant elderly people. This is very important. What is also very important is that a pressure buildup in a room will always be influenced mainly by the intensity of the fire and also the openings in the room. And you have to take measures in order to reduce this pressure buildup. A second one is keeping the door closed is a very easy and very useful measure to limit the smoke propagation. As I mentioned in Flanders, there's a specific requirement that they use self-closing doors in case of fire, and simply doing that will help a lot in limiting the smoke propagation. But again, one measure is not sufficient, so you have to have, in order to have a good smoke control, you have to have a combination of active and/or passive fire safety measures. To end, and I think this is the title of my presentation, that the layout of the building and the application, a possible application of a fire safety measure, will determine if immediate evacuation is possible or not. Because if not possible, you have to go to defend-in-place strategy or stay-in-place strategy. And that is very important, because if this is the only possible evacuation strategy, then not only smoke control will be important, but also the intervention of the fire brigade and human behavior, because these two parameters become now a part of the evacuation strategy. I can inform you that the 3 VIPA studies can be downloaded to the websites that are mentioned on the screen. And should you have any more questions on these studies or my presentation, you can always send me an email. Thank you.
Okay, thank you, Pieter. Really good.
I'm on time?
Yes, you're really spot on time, so that's good. There are already some questions in the chat. We will put them in the table discussion later on.
Yeah.
I have a first question for you. Yeah. We saw in the study that you chose to have a sofa as the fire object.
Yeah.
Can you explain why you chose a sofa?
Well, we used the sofa because it produces a lot of heat, produces a lot of energy. Of course, it produces sufficient energy, but more important was it produces also a lot of smoke.
Yes, yes.
And that's very important. If you want to do research on smoke propagation, you want something that has... Yes, yes. Also, the reason why we used a common sofa or a common couch is because this is something typical in such areas.
Yes, I think it's an excellent choice, because in the Netherlands we see in fatal fire statistics that in 1/3 of the cases furniture is the fire object. So really good choice, I think.
Thank you.
Thank you again.
Thank you.
Okay. Okay, let me go to the next speaker in the program, Ruud van Liempd. Ruud is a colleague of mine. He is a researcher here at the Netherlands Institute for Public Safety. And he was closely involved in the research on smoke propagation in empty residential building, which we talked about in earlier European Fire Safety Weeks. He's also a board member of the Institution of Fire Engineers in the Netherlands, and since August he is the proud father of his firstborn son, Sam.
Fireman Sam.
Fireman Sam, yes, of course, yeah. So welcome, Ruud.
Thank you.
Okay, so how is Sam?
He's doing quite well.
Yeah, keeping you awake at night?
Yeah, at some time. Yeah. At 2 o'clock last night.
Ah, okay. So then you could study a bit on the presentation. Yeah.
That's right.
Okay. Okay. Okay, Ruud. Good luck with your presentation.
Thank you very much.
The floor is yours.
Okay, thank you. Good morning, everyone. I'm going to talk to you today about smoke propagation in relation to personal safety. We did a quite extensive study into this matter in order to, well, let's say, look into a stay-in-place concept. Is it a viable alternative for an escape concept? My name is Ruud van Liempd. I'm a researcher at the Netherlands Institute for Public Safety. A little introduction about myself. I consider myself a fire safety engineer. I like to calculate fire and the effects from fire. I can do that in multiple ways. We can use fire simulations. But, well, what I like to do most is, well, put something on fire, which you can see over here on the, I think, right side for you. We did tests with mattresses. So I can burn things and I get paid for it. So I have a great job, I must say. I'm also an on-scene commander in Schijndel. So I like to combine on the either one-hand side fire safety engineering, but on the other side also fighting the fires and seeing what fires do in the real world. Today in my presentation I will first introduce the subject, why we did this research, what was the setup of the research, what are the results, and we will end up with the conclusions. Well, why did we do this research? We've had multiple incidents in residential buildings with smoke propagation over large part of the buildings. Over multiple floor levels, multiple apartments, we had to evacuate more than 100 people out of the building within just one incident. And we had multiple of those incidents. We're also seeing that there are more people in residential buildings that get older, that are non or lesser self-reliant. So they need assistance to escape from the building. Escaping takes them more time, or it's not even possible. To get inside the building, they use the elevator. They are not allowed to use the elevator during a fire. So we need to look, is there another way for them to be safe during a fire in the building, or to stay safe during a fire? So we wanted to know, a stay-in-place concept, is that a viable alternative for escaping during a fire? And also we wanted to know, the more vulnerable people, how much lower is the reliability of the escape concept for them? Is there really a problem? And if there's a problem, how big is the problem? Well, we already knew that, more vulnerable people and a lot of smoke propagation can be a problem. So we also wanted to know which fire safety measures can lengthen the available safe time. And we looked at it both for an escape concept and a stay-in-place concept. The setup of our research was in basic principle an available safe time and a required safe time. We did it with a zone fire model, and we looked at a few things, one of which was personal safety. The other one was the thermal load for the construction and fire barriers. Personal safety, the main thing is smoke propagation. We have asphyxiant gases, heat, visibility. That can be a problem in escaping or staying safe during a fire. And we looked at the available safe time for 3 target groups: the general group, vulnerable group, and the highly vulnerable group. On the other hand side of the available safe time, we have the required safe time. We put a distribution of the escape time. So not everybody in the building escapes from the starting point of fire. They escape at multiple points in time. With stay in place, of course, they don't escape. They stay in the building. Then you need to determine how long do they need to stay safe inside the building. And we've set the target at 90 minutes as the basic time for the required safe time. It's longer than the fire duration, but you need to consider that even if the fire is out, the smoke in the other apartments is still there. So people can still breathe in carbon monoxide. They can still have buildup of those gases in their lungs, which can be a problem for them to stay safe inside the apartment. So even if the fire is out, you need an intervention to remove the smoke from the apartments in order for people to be safe inside the building again. So that's the reason why we set the basic required safe time for the stay-in-place concept at 90 minutes. If you compare the available safe time and the required safe time, you need to look at, which resident will we consider? And we looked at the individual risk, the worst case residents. So the first person to cross the limit value was the one that we considered in the AST-RST analysis. As I mentioned, not only smoke propagation can be a problem, but also the thermal effects from fire. It can impact on the construction, also on the fire barrier. So that's the other thing we looked at. And we did it in a semi-probabilistic analysis. We varied multiple stochastic variables. Now, one thing is just a technical analysis, available safe time and the required safe time, but you also need to consider human behavior. Is it logical people will stay inside the building during a fire? So we also looked at the human behavior, and Margo Karemaker is going to tell you more about that in her presentation that will follow up my presentation. A few more things about the research design. We've looked at new buildings. We've seen in real fires that existing buildings, there will be just simply too much smoke propagation. So the basic in our research was a new building according to the Dutch building decree. We've looked at 3 types of apartment buildings, all of them with internal escape routes. One with a corridor, which I will focus on today in presenting the results. One with a corridor with openings between different levels. And one with an escape route through an atrium. Now, the other thing that's also important is the fire. The same as Pieter, we've looked at the sofa. And putting the fire into a zone fire model can be quite difficult in getting the input right. We use the smoke propagation experiments in Ouderwater to validate our input, so that we know the input from the fire is solid. We used a sofa because it burns intense, it produces a lot of smoke, and we've looked at the fire will become oxygen depleted before the sofa was completely burned. So we only needed one fire object for us to simulate this fire. And because of the amount of oxygen that is available, the fire will not propagate to other objects. When we look at the thermal load, you will have the biggest effect from the thermal effects from fire when there is an opening inside a building. So a window breaks, then you will have the biggest thermal effect from the fire. And in this case, we use the T-square fire according to the Eurocode. And the location of the fire was in the apartment. If you have a fire in the corridor, you will have a complete different situation. So it's important to understand we have a fire in the apartment in our research. Also important, the definition of the escape and the stay-in-place concept. With the escape concept, in our situation, everybody in this building escapes in case of a fire. If the apartment's on fire, the person in the apartment escapes after 5 minutes. The other apartments, we've had a distribution on the escape times. So the average was 10 minutes, and 80% of the people escaped the building within 50 minutes. So also some people evacuated after 20 or 30 minutes. With stay in place, almost everybody stays inside the building, but with the apartment on fire, the person also escapes after 5 minutes. Because there's no fire safety measure that can guarantee survivability in the fire room, we determined that that person needs to escape from fire, and he does it in 5 minutes. Now, switching from the design to the results of our research, looking at the reliability of the escape concept. The escape concept in a new building without additional fire safety measures. So according to the Dutch building decree. We can see on the x-axis the AST versus the RST, so the available save time minus the required save time. And everything on the right-hand side of the y-axis is a positive thing. You have more time available than the time that you need. When we look at this graph, you can see that for the general target group, we have a reliability of about, I believe, 72%. So in 72% of the cases, everybody gets out safe on their own. Now, when we look at the vulnerable group, the red line, you can see that the reliability of this concept drops to 16%. So it's a lot lower in comparison with the general group. And for the highly vulnerable group, it drops down to 0. So when you look at this graph, you can see, well, okay, for the general group, the escape concept in a building according to the Dutch building decree, it works quite fine. But for the vulnerable groups, it's just not reliable enough. or at least it's a lot lower than for the general group. So now we know for the vulnerable group, and those are the people that might need the stay-in-place concept, the escape concept is just not reliable enough. So now we can see, well, is the stay-in-place concept, is it more reliable? Same sort of a graph, a probability distribution, a reliability graph. But now on the x-axis, we only see the available safe time. With a stay-in-place concept, we've mentioned the required safe time is 90 minutes in the base value. With the general group, you can see that the reliability drops down to about 21%, from 71 to 21, so it drops down a lot. For the vulnerable group, we've had 16%, and it drops down to about 0. So we need another concept than the escape concept for the more vulnerable groups, but it even gets worse with the stay-in-place concept. Within a new building, there's just still too much smoke propagating outside of the fire room to other apartments. One other thing we could do was reduce the required safe time. If we go from the right-hand side more to the left, with 60 minutes, we already have about 54% of reliability for the general group. With the vulnerable group, we increase a bit, but only still to about 12%. So it's still not that much. We used to have elderly people in old age pensioners' home. They would have fire detection and an alarm notification to the fire brigade. There would be internal assistance for them to help them escape in case of a fire. And in that case, a required safe time of 30 minutes might be logical. Well, if we look at 30 minutes, we see about 65% reliability for the vulnerable group. In that case, the old age pensioners' homes were about as much reliable as the escape concept in a normal residential building. But now people need to stay at home longer, and we've seen the reliability really decreases for the more vulnerable groups. Now we've seen two things. One, the escape concept, the reliability drops a lot for the more vulnerable groups. And the other thing is, well, the stay-in-place concept is just not fire safe enough, not reliable enough without fire safety measures. So the next step was to look what can additional fire safety measures mean to lengthen the available safe time. First, a little bit of summary. What I mentioned before, for the general group, the escape time of the reliability of the escape concept, 71%. It drops down to 16 for the more vulnerable group. And in the stay-in-place concept, you can see the reliability for the general group. With 90 minutes, it drops down to 23%. Vulnerable group, it goes down to 0%. So the stay-in-place concept is still less reliable than the escape concept. Now, when we switch to the fire safety measures, on the top hand, at the number 0, you see the situation with no fire safety measures. For the escape concept, we've had for the general group an average escape time of about 28 minutes. And you can see it really drops down to about 6 and 5 minutes for the more vulnerable groups. At number 1, we introduced under pressure in the fire apartment. The idea was when you have under pressure in the fire apartment, less smoke will propagate to the escape route, keeping it safe for a longer period of time. Well, you can see it has effect for the general role group, but not that much for the vulnerable or highly vulnerable group. Then at numbers 2, 3, and 4, we've had 3 different types of sprinkler. One that extinguishes, one that suppresses, and one that prevents fire propagation. The sprinkler that extinguishes means the fire goes out within a few minutes after it started. You can see for all target groups, it really is a big improvement. Now at number 3, we have a sprinkler that suppresses. So it suppresses the fire, it drops down the heat release rate, but it does not put out a fire within a few minutes. And I think with a sofa on fire and a residential sprinkler with a current spray density, the sprinkler that suppresses will be the most likely situation in a real building. We can see an improvement for the general role group, but not that much for the vulnerable group and nothing for the highly vulnerable group. So if we have a sprinkler system, we need it to put out the fire fast. I thought even a sprinkler that suppresses would mean a lot. So not that much smoke will be produced, but because of the longer times we are looking at, there's still too much smoke propagation to the escape route. We've also looked at lower internal leakage area. The idea is if less smoke can leak through doors or other locations, less smoke will come into the escape route. But the main thing is at the moment the person in the fire room escapes from the fire, there's still a lot of smoke going into the door. So we can lower the leakage area, but at the moment you open the door, you have a leakage area of about 2 square meters. So in that case, there's still a lot of smoke going into the escape route. Another idea was an extra smoke barrier. So when you have the corridor, you divide it into 2 compartments. And what you can see is, well, one side of the corridor where the fire isn't, you have a really long escape time because no smoke is going out of the fire room into that part of the corridor. But because the other part of the corridor, the volume decreases, the available safe time also shortens for that situation. So you improve the situation on one side of the corridor, but the situation gets worse on the other side of the corridor. So we need to, look more integrally on the total building in order to consider is that a better situation or not. We also combined a few fire safety measures. So sprinkler that extinguishes with a slower fire, or a sprinkler that extinguishes a slower fire and a lower internal leakage area. In both situations, we've had a longer escape time, available safe time than 30 minutes. So a real good situation for all target groups. Well, we've also looked at fire safety measures for the stay-in-place concept. Again, on the top side at the number 0, the situation with no fire safety measures. So an average of 64 minutes for the general role group, about 37, I believe, for the vulnerable role group, and 21 for the highly vulnerable group. Again, about the same fire safety measures. We introduced under pressure, and it really was quite a big improvement for the general and vulnerable group. Both of groups, 90 minutes available safe time. To be honest, we've introduced an under pressure with a mechanical ventilator in the zone fire model, and it's quite a difficult thing to do correctly in a zone fire model. So we can see that in theory it works good, putting an under pressure in the fire apartment in order to not have that much smoke propagating to other apartments. But we need to test it in real life in order to know, does it work as good as we simulated it? Because it's a difficult thing to put in a zone fire simulation. Then the three different types of sprinklers. Again, the sprinkler that extinguishes really has a big improvement for all three target groups. The sprinkler that just suppresses the fire, it has an improvement for the general role group, but not that much for the more vulnerable groups. So also with a stay-in-place concept, the same as with an escape concept, we need a sprinkler that extinguishes the fire fast. And that might require for a sofa on fire a little bit more water than we have in current residential sprinklers. Also, we've looked at a lower internal leakage area. As Pieter mentioned, smoke propagation is resulting from a few things. On one hand, the amount of smoke in the fire room, the pressure in the fire room, and the leakage area. So if we lower the leakage area, we can lower the amount of smoke propagating to other fire rooms. And we can see it had quite a big improvement for the results. But it wasn't enough for the more vulnerable group. We didn't achieve 90 minutes of available safe time. If we did a combination of a sprinkler that extinguishes, a slower fire, and a lower internal leakage area, we really have a big improvement. We've had 90 minutes of available safe time for the general and vulnerable group, and almost 70 minutes for the highly vulnerable group. And I will tell you a little bit more about the, how to read these results, because the calculation of the available safe times for the highly vulnerable groups, we need to look if our method is correct for the highly vulnerable group. But I will go into that a little bit later. Now, looking at the results for the thermal load, the thermal effects of the fire on the fire barriers and the construction, we've seen that the reliability in case of a stay-in-place concept is lower than an escape concept. 57% to about 90%. If you add 30 minutes of fire resistance to the fire barriers and the construction, you have, somewhat the same reliability for both concepts. So adding 30 minutes of fire resistance is enough to have an evenly reliable fire barrier and construction in a stay-in-place concept. Another option is to introduce a sprinkler. It really reduces the thermal load, and it's a good alternative for additional fire resistance. In this case, you don't need a sprinkler that extinguishes the fire fast. Even a sprinkler that just suppresses the fire really reduces thermal load, so that's also fine. You don't need a sprinkler that extinguishes for reducing the thermal load on the fire barrier and the construction. Now, in conclusion, we've seen that the reliability of an escape concept is much lower for more vulnerable target groups. We already had the idea, and we've seen in real-life fires that elderly or other lesser self-reliant people, in case of a fire, they have more problem escaping. They are more vulnerable for, let's say, asphyxiant gases, heat, or impaired visibility. So we need to do something else. We've looked at the stay-in-place concept, but even there, the reliability is lower. It is much lower for the general target group, and it's a bit lower for the vulnerable target group. And the vulnerable target group, that was the group we thought the stay-in-place concept might be, that's where the escape concept doesn't really work that well. So that's why we thought, maybe a stay-in-place concept is a good idea, but it's just not enough to just say, well, we have a stay-in-place concept in a new building. You need additional fire safety measures. And one really important thing to consider is that even if you have a stay-in-place concept, there are, at this point in time, no fire safety measures that can guarantee survivability in the room with where the fire originates. So you need also to escape from fire in the room where the fire is. Even with a stay-in-place concept, you can't stay in place in the fire room. As we mentioned, you need additional fire safety measures for the stay-in-place concept. Two important things: reduce the amount of smoke that is produced by the fire. Two options: fire-safe furniture and sprinkler will work really well in that case, and also reduce the smoke propagation. And well, you can lower the internal leakage area. You can, as Pieter mentioned, reduce the intensity of the fire, again with a sprinkler. That will also reduce the smoke propagation. So those are good fire safety measures to lengthen the available safe time in case of a stay-in-place concept. Two things, well, we need to look into a little bit further after this research. In this research, we've looked at individual risk. The worst case resident, the first person to cross the limit value for the available safe time. But with the stay-in-place concept, if everybody stays inside the building, if something goes wrong, the effect is much bigger. So maybe we need to look at the risk of the total building and compare the risk of the total building for the escape concept and the stay-in-place concept. We need to add that to our risk analysis. And the other thing we need to look into further is our calculation method for the escape and survivability, is it suitable for a longer time duration? It's the method from David Purser. We know it works for an escape situation with longer or with shorter times of, well, let's say breathing in smoke, having heat coming onto your body. But does it work for longer time periods, which we need in the stay-in-place concept? We've seen, for instance, with heat, that it probably doesn't work that well. Especially for the highly vulnerable groups, because they have a lower limit value. So those are two things we need to look into a little bit further. And of course also the human behavior, which Margo will tell you a lot more about it. If you want to get into the content more deeply, this is the link to our research. Unfortunately, it's in Dutch, but Google Translate might help you a lot with that. And well, thank you for your attention, and all the questions we'll cover in the roundtable discussion later.
Thanks, Ruud.
Thank you.
Thanks for this good presentation on a really difficult topic. I think.
Yeah.
Thank you, Ruud.
A difficult name for the target groups.
Yes, yes. It's kind of difficult for Dutch people. Yeah. But you did really well. Okay. So let me give you a first question. What did you find most striking about this research?
Two things, maybe. I knew we've had a problem. Well, I thought in a new building, the stay-in-place concept would work better. I thought it would be more airtight, but I think maybe only the outside of the building, the facade, is really airtight, and the inside, it is just not really that airtight yet. No. The other thing was, I thought a sprinkler that suppresses the fire would be good enough for a stay-in-place concept. Yeah. But still, there's just too much smoke produced because the fire goes on a little longer. And because of the long times in the stay-in-place concept that you need to stay inside the building, even with smaller leakage areas, there's still too much smoke going.
You need to be secure that you're in a safe place if you want to stay. Yep. This is a kind of new way of thinking, which is quite difficult to pinpoint exposure limits on.
Yep.
I think. Yeah. Okay. Thanks a lot.
Thank you.
Let me go to the last speaker, Margo. Margo is also a colleague of mine here at the Institute for Public Safety. And Margo is specialized in human behavior and influencing human behavior during fires. She's doing her PhD thesis about influencing human behavior of elderly people. She recently completed a lot of experiments on the possible behavioral interventions for the elderly. You had 280, 260?
260 elderly people, yeah.
What did you do? What kind of experiments did you do?
We did more of an active, interactive kind of intervention, so education. So not only telling people what to do, but let them experience in different scenarios what the best behavior, what the most fire-safe behavior would be.
And this was in kind of small groups with elderly?
Yeah, small groups. So we did 20 people at the same time, but we split them in 3 different groups. So we worked in small groups, so people had time to ask questions about their own situation at home. So you can intervene in their own personal situation, so to say, instead of telling a general story about what people should do in theory.
So really talk with them.
You talk with them, yeah.
Yes, instead only to them.
To them, yeah.
Okay. Okay, so let's go to your presentation. You will do the same topic as Ruud, but then from the perspective of human behavior. Yeah. So good luck with your presentation, and I'll come back after it's done. Yeah?
Thank you. Yeah. Let's see. Hello, everyone watching this webinar. Lieuwe already introduced me. My name is Margo Karemaker, and I work as a researcher at the Netherlands Institute for Public Safety. And I was involved in the same research as Ruud was talking about in the previous presentation, but I focused on the more human behavior perspective. So I would like to talk to you about that in the next half an hour. What kind of human behavior can we expect in practice? And what do we need to take into consideration looking at both an escape concept as well as a stay-in-place concept? A short introduction about myself. Well, I already said I work as a researcher. Lieuwe already told that I'm also a PhD candidate at Maastricht University. And I've been working on developing the intervention that we tested the last few weeks on how to improve the fire-safe behavior among elderly people. So it was interesting. We had 260 elderly people visiting us, and now we're working on the analysis. So hopefully we'll see an effect of this type of intervention. So we know what's the best way to influence their behavior. I'm a behavioral scientist, so I like to do research into human behavior. Why do people do what they do? What can we expect from human behavior? What kind of human behavior can we expect in certain situations? And what do we need to take into consideration looking at different situations when we talk about it in research? Ruud and Pieter, the presentations before me focused on a more technical perspective, but I would like to talk a little bit more about the human behavior perspective, because that's an important thing to take into consideration as well, if you ask me. Ruud already explained what we did in the research that was about smoke propagation and personal safety. We looked at human behavior from a qualitative perspective. So we did some literature analysis to find out what kind of behavior can we expect. What do we see in practice? What is already known about human behavior in these 2 concepts? So both the escaped concept as well as the stay-in-place concept. And I think that was very interesting about that research, because it was, well, I think I can say the first research in this institute that combined the more technical aspect of fire safety engineering with human behavior. And what I see in practice is that in most cases we focus on one or the other. So we focus on the engineering part, talking about fire safety, or we talk about influencing behavior. But looking at those things apart from each other, if you only focus on engineering, I think that could be a solution, but then your technical provisions that you're talking about should be completely behavior independent. So you have to be sure that human behavior cannot influence the provisions that you are installing in the building. On the other hand, when you're only looking at influencing behavior, you have to be sure that people will act the way you want them to, that people will always display the desired behavior, so to say. Or you have to be sure that human behavior is getting predictable. If you are sure what people are going to do in a certain situation, then you can keep that in mind with the research that you are doing. But I think that's still very difficult to predict in a specific situation what people will do. In my opinion, you should combine these things together, and that's what we did in the research into smoke propagation and personal safety. The technical part is already talked about, so I will talk about human behavior. I will start with a short introduction about human behavior in general. What can you expect from people in the event of a fire, and then looking at the two concepts, so the escape concept and the stay-in-place concept, and talk about what can we expect and what do we need to keep in mind when we are looking at these concepts. In general, in dangerous situations, people act in 3 different ways. And I think that's for most people that is known, because then we talk about fight, flight, or freeze reactions. Looking at human behavior in fire, you can see, again, these 3 types of reactions. And then with fight, we mean fighting the fire or take action and rescue people. One of the factors that influence if people are going into fight modus is their gender. We can see that in general, men are more likely to start fighting the fire than women are. And also role is an important factor that will influence this kind of behavior. For example, in nursing homes, the caretakers, they will be more likely to fight the fire instead of the people who are living there or the people who are visiting families that live over there. Social norms is also a factor that can influence if you're fighting the fire. I think it's linked with role. If your role is the one who's taking care of the people in the building, it is expected that you are going to act in a certain way when there's a fire. So it's almost expected from you that you start fighting the fire in the event of a fire. About fleeing, so the fight, it's more the flight modus. People can flee to a safe environment, and you can see that it's mostly the cases with the self-reliant people, because those people can move to a safe environment. But the people who are less self-reliant, for them it's more difficult, because they are not always capable of moving to another place in the building. So the flee modus, so to say, is more for the self-reliant people. The last one, which is the freeze modus, that we call the freeze modus, is actually people who are going to wait to be rescued. And that could be the case if the escape route is blocked by smoke, for example. People don't have an option in that case, so they have to wait, ideally, in their own room until the escape route is free from smoke again. What we see in practice is that people still decide to escape through the smoke. So it's very important to tell people and to attend them on the risks of smoke, because in practice, when I talk to elderly people in my research, what I see is that people think that fire, the flames, is the dangerous part, but they are still not always aware of the risks of smoke and the toxic gases which are in the smoke. We now know that the smoke is actually more dangerous than the flames, because the smoke will spread through the building sooner than the flames will, but people still think that they can escape through the smoke because the smoke is not that dangerous. So that's something important to keep in mind when you're talking about risk communication, for example. Another thing is that people also underestimate the development of a fire. So they underestimate the time which a fire needs to develop into a bigger fire. In my research, when I talk to elderly people and I ask them, how long do you think you have after a fire starts to leave your own house, then many of them said that they think they have 10 to 15 minutes. But in practice, we see that the fire will spread more faster, because we always say that you have 3 minutes to get out of your house after a fire before the survivability will decrease. So that's something to keep in mind. People are not aware yet of the risks of smoke. A way to be rescued, of course, people who are not able to escape to another, or escape from the building or flee to another room. They will also wait in the room until they be rescued. Establishment of behavior, our decision-making process, will follow 3 different steps. Step 1 is perceiving of signals. You have to become aware of what's happening around you. You have to recognize those signals. Step 2 is about judgment and decision-making. If you perceive certain signals around you, you have to interpret them and think about the actions. What can you do? And then people move on to step 3, which is the action phase. People will decide to escape, for example, from the building. I would like to talk about these three steps focusing on the escape concept. First, about perceiving signals. I think you can imagine that if someone has visual or hearing impairments, or someone is sleeping, it will take a longer period of time before they will perceive the signals around them that aware them that there's a fire in the building. So that's maybe an option that you've already thought about. Another option that can influence the perceiving of signals is the location where people are. Of course, the closer to the fire you are, the faster you will perceive the signals that will attend you that there is a fire in the building. And we also see in practice that people who are further away from the fire, when they perceive signals, so when they start to see smoke, for example, or they hear people around them making noises or screaming, or they notice that people are escaping, the people who are further away from the location of the fire will take some time to verify that the fire is real. So it's also something to keep in mind. People whose location is further away from the fire will take more time before they decide to evacuate from the building. Receiving consistent signals is also something that contributes to the fact how people perceive signals. If you perceive it, or if you see flames and see smoke or smell smoke and you feel the heat, so the more signals, the more consistent signals that will aware you of the fact that there is a fire in the building will contribute to the fact that you move on to step 2, which is the interpretation and decision making. Another thing that has a positive influence on how you perceive signals and perceiving them as being a fire are social signals. So I already said, if you hear people from the building screaming, for example, or you hear that something is going on, then you will be more likely to perceive those signals as being serious and think that there's really something going on, so you need to make a decision about what you're going to do. And if you receive those signals from known or official sources, so for example, from a family or friends or the fire service, you will also perceive the signals that make you aware of a fire as more serious. But perceiving signals is something that's very complex, and that's what I want to show you, but by the picture that's on the sheet. In this picture, you see 2 different squares. The top one is a more darker gray, and the bottom one is more lighter gray. But it's all about perception, because if I put a line on the place where the 2 squares are coming together, you will see that actually they are the same color. So perceiving signals is complex, and our brain is a complex thing. So perceiving signals, also the environment has an influence on that. I will show you again, so you don't know, or you know it's not a trick. It's really that simple. So put a line over it, and then you see that they have exact the same color. Step 2 is about judgment and decision making. We also see that there are some factors that influence this step in human behavior. And one of them is experience. People who have experienced a fire in the past will be more likely as perceiving the signals that they receive as being serious. So people who've experienced a fire will sooner go to step 3 and take action. Looking at age and gender, we also see that elderly people and women will also interpret the signals that they are receiving sooner as being serious and acknowledge the fact that there is a fire, so they should take action. Knowledge on the building, on the other hand, is a factor that can influence this step in a more negative way, so to say. So people who have knowledge of the building will take more time to find out what's going on, to have a look around, because they think, I know how this building looks, I know where the fire exits are, I still have some time, I'll manage if I decide that I have to escape from the building. So people who don't have knowledge of the building where they are, so because they are not coming there very often, they will decide sooner to move to step 3 and take action. Some other factors that are influencing the judgment and decision making are uncertainty of the situation. People who are not certain if there is a fire or not will look around, start asking other people to verify if the signals are serious and if they have to do something, if they have to escape from the building. Well, knowledge and experience I've already talked about. Another factor is behavioral scripts. I've been thinking about how I can explain this in a quite simple way. Behavioral scripts is actually if people go to a certain location with a certain goal, and then there's a fire, then they have to behave differently than what they assume to do, so to say. Well, to mention an example, we see in practice that people who are go to a shopping mall, for example, and then you see them shopping clothes, and there is a fire in that store, we see that people just continue going on shopping because that was their goal, that was what they came to do, and they find it very difficult to move away from that behavioral script. So we see that people see the flames, they feel the heat because the fire is quite close in some cases that we see in practice, and they still decide to go on with what they were doing because that was what they came to do. So behavioral script is something to keep in mind, and that can influence judgment making and decision, or judgment and decision making. Another factor is the behavior of others. If you see so-called social norm, if you see other people around you take action, perceiving the signals as being serious and escaping from the building, you will be likely to do so as well. But we also see examples of people who are in a room, and then, for example, the fire alarm goes off, and people start looking at each other, trying to find out who is going to be the first one taking action. So then the behavior of others can influence your decision-making in a negative way, because no one wants to be the first one to take action. People are looking at each other, what are we going to do? And then in practice, you can see that people will stay in the room where the fire is, or where the fire quite close to is, for a longer time than what you want them to do. So also the behavior of others is something to keep in mind, for example, also in behavioral influence. Then step 3, human behavior, the action phase. We always talk about pre-movement time, and what I mean with pre-movement time is that when people decide that they have to escape from the building, from that moment until the moment that they actually move and escape from the building, there's always some time. That's called the pre-movement time. You have to think about this time as the time that people use to warn other people in their building, for example, or in their own home. They are going to collect some stuff that they want to take with them when they are escaping from the building. So the pre-movement time, on average, is less than 5 minutes, but we see that people take some time before they leave the building. And in residential buildings, the pre-movement time is a little bit higher than the pre-movement time in other types of buildings. And that is because people, for example, in residential buildings, are more attached to their own stuff, so they take some more time to collect their stuff before they leave the building. Talking about escape routes, what we see in practice is that people often choose the escape route as being the way which they entered the building. So we see that in theory there can be multiple escape routes from the building where the people are in, but looking at what they do in practice is that most people will choose for the main entrance because that's a route that they already know and they use in daily life, for example. And what you then see is that people say, yeah, that route feels shorter, even though there's an escape route that might be theoretically shorter, but the other one, it feels shorter because they walk it several times in daily life. So keep in mind that we can talk about different escape routes, but people will be likely to choose the route that they are most familiar with. And talking about the difference between daily behavior and behavior during a fire, also closing door is important to keep in mind. In theory, you want people to close the doors behind them to stop the smoke spread of smoke from spreading through all the building. But in daily life, closing doors behind you is not something you always do. It's not your general or normal behavior. So closing doors is a kind of new behavior in the event of a fire. And that's why we see that in practice, people do not always close the doors behind them because, they're not thinking about it. It's not in their system. Walking speed, I don't know how it is in other countries, but in the Netherlands, in building regulations, we assume that people walk with the speed of 1 meter per second. I think you can imagine in the event of a fire, that's not the case for all people in the building, especially the less self-reliant people or the less mobile people, I have to say. The question is, can they walk with the speed of 1 meter per second, maybe even through the smoke? I think that's not possible. That's not a realistic perspective to look at the walking speed. Because elderly people, for example, we talked about elderly people a couple times this morning, people who are walking with a walker or a walking stick or need help from others to leave the building, they will not be able to walk with the speed of 1 meter per second. So you have to keep that in mind as well. technical provisions, we can focus, as I said, on looking at my first sheet on the engineering part, to focus on technical provisions. What is important to keep in mind is that the technical provisions have to match the daily behavior of the people who are living in the building. An example that I like to use are the door closers. We see that the door closers are being installed to keep the people safe in the event of a fire and when the smoke spreads to the building. But what you see in practice is that people will find the door closers annoying or unnecessary because they don't know why they are installed and why the door is always closing. So you see that people put something in front of it so the door stays open, or dismantle the door closer so it doesn't work anymore. So talking about technical provisions, yes, they can improve the situation and the escape route that people, or the safety and the escape route that people should use. But it's important to keep in mind that the technical provisions have to match human behavior in daily life. Talking about the stay-in-place concept, the two presenters before me, Pieter and Ruud, also talked about how you can ensure or improve the safety in the building when talking about the stay-in-place concept. The construction measures are things that can improve the safety in the building when you want to implement the stay-in-place concept. And also a combination of source-directed measures, for example, fire-safe furniture, and effect measures, focusing on smoke resistance can improve the fire safety in the building, which could make it more safe for people to stay in their own apartment for a longer period of time. But as I already said with the example about the door closer, is that human behavior can influence technical measures. So you have to keep in mind that the technical measures that you install have to match the daily behavior of the people, the inhabitants, so to say. Also, talking about stay in place, I think we can imagine that if you're always being told in the event of a fire, you have to leave the building that you are in, and now we are adjusting that advice into you have to, and sometimes it's more safe to stay in your own apartment in the event of a fire. I think we can imagine that people will still have the urge to escape. It can feel very unnaturally if you maybe even see that there's a fire in your building. You can see maybe some smoke outside of your window. And then the advice is to stay in your apartment because we say that's the most safe situation where you can be at that moment. It feels very unnaturally, so it's important to keep that in mind. And I think that we will see in practice that people will still try to escape from the building, even if we tell them not to do so. If they stay in their own apartment, if they decide not to escape, one thing we can see is that they can also decide to open a door for a short period of time, just to have a look at what's happening in the building, for example. But opening the door can already influence the safety conditions in their own apartment, because then the smoke, which might be in the hallway, can enter their own building. So opening the doors can actually decrease the safety conditions in the apartment where they have to stay in. So again, human behavior can influence those safety conditions. And there could be, in general, there could be a resistance against the stay-in-place concept. There was a study in the UK that was being done, and people were asked, the advice is to stay in your own apartment in the event of a fire. What do you think you would do? Would you stay or would you leave your building? And people say, I think it was only almost 75% of the respondents said, I will not stay in my apartment, but I will leave the building. Or because they did not trust the construction measures, or they say, I don't want to wait until someone is going to rescue me. I want to take action by myself, so I will decide to leave the building. I have to say that this study was done in the UK quite close after the Grenfell fire. So I think that would have influenced the results. But it's important to keep in mind that those kind of fires can influence how people think about a stay-in-place concept and if they trust this kind of concept. Some conclusions. I mentioned different factors that can influence the required escape time, but also different factors that can influence human behavior. I think it's very important to include human behavior in simulations. Use information about human behavior in practice if you are going to make a simulation or work with modeling of a fire, because you cannot expect that, for example, people will spread evenly over all of the escape routes that are available. But keeping human behavior in practice in mind, I think, will improve the reliability of your simulations or modeling. Ruud van Liempd also talked about the escape concept not being suitable for all groups. But I have to say that the stay-in-place concept is not simply a solution. The stay-in-place concept requires adaptation of the building, but also maintenance of the building to keep the environment suitable for this kind of concept. And making sure that human behavior will not influence the technical provisions that you are going to install. A link with that, the implementation of technical measures must match with human behavior. As I said, the door closers, for example, is something that we can think of as improving the safety in a building, but looking at human behavior, it doesn't match behavior in daily life, so people might influence the technical provisions that you have installed. And last but not least, risk communication is very important, especially in the stay-in-place concept. If you want people to stay in their own apartment for a certain period of time, please use communication, preferably by spoken word, to tell people why it is important to do so and why it can improve their own safety. That's some introduction in the basics of human behavior. Thank you very much.
Thank you, Margo. Thank you for this really good presentation about human behavior.
Thank you.
And well done in time.
Thank you, yeah.
We're running a bit in front of the schedule, yeah. But that's okay. That leaves us more time for a bit of discussion. The first question for you, importance of human behavior. How much can we expect from different vulnerable groups? Can we expect some kind of behavior from them?
I think Ruud also mentioned the difference between vulnerable groups and the highly vulnerable groups. I think we should have a look at the self-reliance of people. If people are still self-reliant and they can escape if they have to, then I think you can involve them in the plans that you're making, so to say. Yeah. But I think for the highly vulnerable people, especially the less self-reliant or the non-self-reliant people, yeah. We have to think of other measures.
Yes, when they're not self-reliant, they cannot escape. So no. They need other things. Yeah.
Yeah.
Okay, thank you. Okay, I will ask the other speakers also to join us. Now we'll move a bit. And we could have a kind of small table discussion. Welcome back.
Thank you.
Let me see. There are some questions here from the audience. Let's start with Pieter. Pieter, can you tell a bit more how the VIPA studies were funded?
They were funded by the Flemish government. This was this VIPA who funded these studies. For the second and the third, it was so, but also for the first and the third, sorry. The second, also the industry had a large participation in this study. So they not only delivered material, but also they funded a little bit the study because it was specific on smoke control, innovative smoke control systems.
Yeah, and because of the government was also a partner, their aim was to get it inside of the regulation?
Well, you have to keep in mind that the purpose of the studies was to look at a derogation of the legislation. So we have seen that it's because of the common area being placed in the evacuation strategy, this is not foreseen in the regulation. And that's the reason why they did this study. They want to see what kind of fire safety measures can or cannot be applied in order to guarantee a safe
so first it was only to figure out which one were right or not.
Yes. Yeah.
And that could lead to some kind of...
They use, I did mention it very briefly, because the VIPA studies led to an assessment framework. And that assessment framework describes what kind of measures you can use. So there are different kind of measures you can use depending on the layout of the building. And so there's no one specific...
So with framework, you mean it's kind of a table?
A table saying that if you have that situation, you want to apply that has the consequence of that, can have an immediate evacuation or not. In that case, it's only applicable for the defend in place. So it depends on a lot of
yes. Things. Okay, and that will be in the last report, this framework?
Yes, this is mentioned in the last report.
Okay, thanks. Question for Ruud. A really technical presentation. In the presentation, we saw that there's a big difference between those groups as it comes to reliability. So what is your, how does it, why is this? Why is there a really big gap?
Well, with the higher vulnerable groups, they are more susceptible to heat, visibility, or asphyxiating gases.
So it's mainly the exposure limit. Why is there a big difference, or?
What do you mean within the available safe time?
You had this table where it comes to reliability, and then there you saw that I think the general provisions we take in regulations are mainly focused on the general group and not on the other groups.
True.
And now we see actually that there's a big gap between them. Is this gap only due to the exposure limit, or does it also have to do with something else?
Yeah, also with, well, the ability of people to escape in case of fire and how fast they can escape in case of a fire. If they need assistance, if they need aids, walking sticks or anything else, are they able to escape in an elevator, or can they also use a stair?
Yeah.
Those are all factors that are that influences the escapability in case of a fire.
Yeah. Yes. Okay. Thank you. There's another question here. Hi, Ruud. Was the flammability of the materials in the room checked? The furniture, for example, and standards, or makes a huge difference, I suppose.
We know if we use fire-safe furniture, that makes quite a lot of a difference. In this point in time, at least in the Netherlands, there are no regulations for furniture. And we know that furniture is the most intense fire that is possible inside a residential building. It produces the most smoke. So if you take away that fire, it will improve the results. Yes, real-life fires.
But still, there would be other furnishments, and they can burn, of course.
Yep. But you take away the fastest growing, the most intense fire you take away.
Yeah. Okay. And in both your presentations, we already talked a bit about strategies. There's a lot going on in definitions, I think. Stay in place, defend in place, stay put. It looks kind of the same. Ruud, can you explain stay in place for the definition we used again? Because we see some questions about this.
Yeah, okay. So the definition we used was, in a stay in place concept, everybody stays inside their own apartment, except the person in the apartment that's on fire. Because there are no fire safety measures guaranteeing survivability inside the apartment that's on fire. So that person or persons have to go outside of the apartment, and all the other people stay inside their apartment.
And if I understood correctly, we also put in the definition that the fire brigade or fire service is not a part of this strategy.
So no, it's not part, but I talked a little bit about the required safe time in case of a stay-in-place concept. Because the smoke doesn't go out of an apartment in,
somebody has to do this.
A magical matter. The fire brigade has to come inside, extinguish the fire, and ventilate the smoke outside of the apartments.
Yes, but for
it doesn't mean that they need to assist the people to the outside or evacuate the building, but they need to bring back the conditions inside the building to a normal matter.
But I think that for the safety of people in other apartments, it's not necessary that the fire service does some kind of smoke control.
Well, if there will be no fire brigade, how long would the required safe time be?
Yes, that could be even longer.
Ventilation of apartments is just really slow. It's just normal day-to-day ventilation. So smoke or carbon monoxide concentrations could be in that apartment for more than days.
Yes. So actually, that's kind of the question yet. How long do we need to be sure that people are safe in their apartment? Actually, they should be safe for the whole fire scenario and even the aftercare.
Yep.
Okay. And but this is kind of different, because if you have a stay put or a defend in place strategy, then mostly it focuses on, you stay in a safe place until you get evacuated. Is that?
No. First of all, you stay in your room.
Yeah.
So that means that during the fire or smoke and the evacuation route, you have to stay in the room because, as I said, in the Flanders, you cannot be exposed to smoke. But once, for instance, the fire is out, or the smoke is still there.
Yeah.
And for us, the evacuation is from the room to the exit, and not. So that means that the whole evacuation is when they are outside the building, or in the case of a horizontal compartmentation in a subcompartment. So that means that you have two phases. First of all, you stay in place, but after that, you have to make sure that the evacuation route is made smoke-free in order to, that moment, do your evacuation.
Yeah. Okay.
And that thing is...
Yes, okay, thank you. Thank you.
But I agree, it's a matter of definition.
Yes, we would work on, we should work on good definition.
But we mean more or less the same.
Okay, okay. Margo, if you hear those two guys talk about this, it's all kind of a technical thing, and it focuses on kind of accepted or some behavior that it would go on.
Yeah.
How are you listening to this?
Now I can understand why they are telling the things they are doing, because ideally you want people to behave in a certain way. So looking at the technical provisions or the construction measures, I think it's a normal reaction, so to say, to focus on the behavior that what people should do. But I think you can, but then there's an important step that is actually quite parallel with it, that you have to focus on human behavior as well. So involve people maybe in what you are talking about, but also focus on the importance of certain construction measures and how that can contribute to the safety of the people in the building. So that's already some kind of start with influencing the behavior of people in the building. So I think...
and in Ruud's study, we saw there were 3 groups. Could you say that human behavior is more important for one group than the other, or the behavioral influence is more important, or...?
I think you can say that, but then especially focusing on the self-reliant people and maybe even the vulnerable people in comparison with the highly vulnerable group of the less self-reliant group. Because if people cannot escape from the building by themselves,
they need help anyway.
They need help anyway. So then you don't have to focus on their behavior so much, but more on the people around them who can help them in the event of a fire and who have to assist them in the event of a fire.
And then the people who help them are...
Actually, the persons, you need to reach.
So actually, behavior is always important.
Yeah, I think so. Yeah.
Yeah. So, and if from my point of view, if you look at those different groups, as I told you, mainly we focus for regulation on the general group.
Yeah.
We kind of forget the other groups, and then the middle group. Those are the people who think that they are reliant, and mostly in daily life they are reliant, but in case of fire they are less self-reliant. So. Isn't this the kind of the difficult group then, or? I
think so, yeah. And I remember that at the beginning of this year we tried to come up with some advice for people what they should do in the event of a fire. But then you see that it's very difficult because people have to make their own decision and they have to interpret the signals and make their own decision about the situation. And if people are very confident about what they can do in the event of a fire, but in practice you can see that actually they are not, then I think then we have a challenge on how to inform and influence these people, because they will be confident about what they can do. And I think in this group you mean, for example, the people who are walking with the walkers or a walking stick. I think if you ask my grandma as well, she would say, I'm perfectly capable of escaping in the event of a fire.
And
but
then
in
go
practice,
to the elevator and the elevator's not working.
Exactly. For example, so I think that's the most difficult group maybe to influence, because their perceptions are different than what we know from.
Okay, I have another question here for you. Would you recommend behavioral specialists present at large incidents to assist the fire chief commander for risk communication?
That's interesting. Could be interesting, because behavioral scientists, I assume that they have more experience with how people perform in the event of a fire, what we can expect in practice. So, for example, to stay with the example of the fire exits, if a fire commander expects that people will spread all the way through the building, but a behavioral scientist can say, well, keep in mind that the majority of the people will try to leave the building from the main entrance, then I think that would be an interesting idea that can maybe even improve the...
On the other hand, maybe it's not easy for your fire commander to have all the information.
That's the other side.
Ruud, you're a firefighter. How do you look at this?
Well, you have a lot of things going on. But if somebody can do the analysis for you and say, well, if you can do an intervention to keep the main exit smoke-free or something like that, that would really help. But another thing is we could add it into the lessons we give firefighters up front. The lessons we teach firefighters.
Yeah.
We could implement behavior analysis into that more than we do currently, I think.
Okay. Let's go back to a bit of the part of your two studies. I think Ruud explicitly showed something between individual and group risk.
Yep.
I think in your study it also looks, for example, mostly on the individual risk. How do you look at this? Because you could also say, why look individual? We should look more at the group level, and then maybe there will be another safety level. Is this something to consider, or?
Yeah, as I mentioned, that's one thing we need to look into further. In our study, we focus on individual risk because that's also the basis behind the Dutch building degree. But I think if you really want to compare an escape concept and a stay-in-place concept in a good manner, you will need to look at the risk of the total building.
Yeah, total building is something else than group risk. Or
well, I mean the group of people that are inside the building.
Okay. And Pieter, how do you look at this?
Well, you have to keep in mind that the purpose of our study was if you have a lot of combustible materials in the evacuation route.
Yeah.
So we focused more on how can we assure a safe evacuation. So you have to keep in mind at the end, your basic evacuation strategy must be immediate evacuation.
Yeah.
What we have seen, if you apply a lot of combustibles in the evacuation route, it's not possible to have that immediate evacuation unless you have a fire safety measure, the fire screen, you create a smoke-free evacuation. But suppose you cannot do that because of building geometry, you're forced to apply a defend in place. And that means there's no other choice. Or you just follow the requirements of the legislation, and then it's fine. So you see, it's all because of new open architecture, new base of building that comes with other dangers of fire safety.
Yeah, and we see that elderly in total is growing. So the idea is, I think, that there would be other building plans with all kind of different.
It's applicable not only for homes for the elderly, but for instance for hospitals. It's the same thing.
More care solutions as well.
Other buildings that have the same principle. Yeah. You apply a fire load in an evacuation route.
Yeah.
And that's, according to me, and no legislation allowed.
No, I think so, yeah. I agree. Okay, so if we look a bit to the future then, hey, you showed us all different things to keep in mind or to look into, and I could imagine that if somebody is looking and saying, "Whoa, this is a lot. I have to deal with a lot of things." What would give us more flexibility if you look at the future? For example, if you look at measures or.
Well, maybe to start off, fire-safe furniture. If we have more fire-safe furniture, we take away the most intense fire that produces the most smoke. So it will give us more time inside the fire room to escape, but also outside the fire room. And in order, also an addition, a sprinkler. If we have more residential sprinklers, it would really help us a lot in order to have less effect from a fire.
So actually, you mean we should keep more focus on keeping the fire small, and have not a lot of smoke production, smoke propagation. Yeah.
You keep the fire small, and everything after that will go easier. If it's escaping, staying in place, fire intervention, fire internal assistance, everything really improves.
Yeah. Okay, and Pieter, I think you said this in your presentation, it's always a combination of active and passive measures. Is this also something what you think of that?
Yes, but again, in Belgium, we don't have the concept of smoke control in the legislation.
No.
So this is, I think, different than what you have here in the Netherlands.
Yeah, actually, the question was about this. Somebody asked, okay, now we have some results from Belgium and from the Netherlands. How about Europe? How can we ensure this better in Europe?
Well, in the first VIPA study, I looked also at other countries, how they deal with smoke propagation. And you see then some countries are already have smoke control compartments and so on in their legislation, others don't. So we have seen now with the VIPA studies, this for some kind of people, it can be a problem.
Yeah.
For self-reliant adult people, I don't see much problem if there's a little smoke propagation. But if you have vulnerable people, then it's completely different.
So then, is it actually what you're saying? We should choose if we want general or more specific regulation measures?
But you have to keep in mind the legislation is for new buildings or existing buildings, and if it's existing, it becomes more difficult because then you have sometimes to modify things in your building, and it's not always possible. But at the end, it's like Ruud was saying, it starts with the smoke propagation. And as I mentioned, it's all because of the pressure, the pressure buildup in the room. If we can eliminate that, there's already a lot of things we can help with. Yeah.
Yes. Okay. So a lot of choices we can make to make it better. Margo, at the end you said risk communication is important. What is your advice?
I think you should inform people, actually, for example, when they move to a certain building, about what are the options in the event of a fire, what are the escape routes, but also so more on the preventive side, so influence people before the fire is actually there. I think at the moment or in the event of a fire, it would be good, and I think you can also see that in literature, to give people instructions by spoken word. So you have installations that you can install in a room, for example, so the fire service or someone else that they trust, because that's also important, who is going to share the information. But then if the fire service can, well, some kind of actually talk to them by spoken word, because now it's for you it's more safe to stay in your own apartment. This is what you have to do. This is why we decide to do so or to give this advice. I think then you can actually
influence them during a fire. Actually.
Yeah.
But then you really need to know what the conditions are and where they are.
I know. That's why you need technical people like Pieter. Yeah, that's why they are. Because I think then you should inform them about the situation. But you need information about what the situation is and does everybody has to
before there's a fire? Could that also work or help?
I think so. Yeah, I think if you're talking about an escape concept or a stay-in-place concept. In the Netherlands, for example, people grow up with the idea, in the event of a fire, I have to leave the building. But if you can inform them upfront about why in some cases it would be more safe to stay in your apartment in the event of a fire, then I think that will help when the situation is actually there.
Yeah, and there's another question I have. There's a lot about talk about different strategies. But nowadays, we see that smoke propagation is a problem. Even when we teach people you have to go out of a building, they can become in a situation where they cannot escape. So should the risk communication be about the strategy, or should it be more, in general, about what to do in case of fire?
And you mean about the strategy, why the strategy?
Yeah, so in the Netherlands we have evacuation strategy. We tell everybody from child on, you have to go outside the building when there's a fire. But then they can also be in a situation where they cannot escape. This is also kind of a contradiction then. Yeah,
it is. And the challenge is, do the people who are in the apartment, are they the ones that are going to have to decide, is the situation safe so I can escape from the building? Or is the situation now that dangerous so I have to stay inside of the apartment? So the question is, who has to make the decision?
Yes, okay.
And that's difficult,
okay. Okay. Another thing you mentioned in your presentation is that we should include behavior in simulations. Do we have an idea about that, how we should do that?
Yeah, I think it's being done already in some countries. And an example that I've seen in the literature is, for example, about how do people evacuate and the evacuation exits. What I heard that it's more easy for people who do the simulations, that they say, well, I'll just assume that everyone will spread quite evenly through all of the possible fire exits. But if you look at what human behavior is in practice, then you can see that that's not the case. So then, for example, in your simulation, you can move more people to the main entrance, so you can involve human behavior in practice in your simulation. So I think in that case you get a more realistic simulation, which includes human behavior.
I think we need to connect the evacuation simulation. Of course, we need to input behavioral analysis, but we also need to connect the evacuation simulation to the fire simulation, because those two interact. If a person opens a door, it does something with the smoke propagation, it does something with the oxygen that can go to fire. So we need to connect the fire simulation and the behavioral or evacuation simulation.
Yeah, so also put in behavior in the asset, in the asset simulation, not only just in the required safe egress time, but also in the available safe egress time.
Usually do right now is we make a fire simulation. We try to take some input from the behavioral side, so doors are open or not, and we do evacuation simulation.
Yeah.
But there are currently some new innovations which within every time step you can have an interaction with those two.
Yeah.
So like a real life fire simulation, integrated behavioral and fire.
Yes, okay. Okay, another question here is about the measures you put in your research. What about other measures? For example, water mist. You both looked into sprinkler. What about water mist? Would that also be a solution?
Well, we used a residential sprinkler system because you have to keep in mind, again, it's a derogation. And if the Flemish government want to refer to a system, they want to refer to a European standard where the system is, and water mist was not at the moment is not so. So that's the reason why we use a residential sprinkler.
But would it work, or?
It depends on what you want to obtain. Again, if it will not help if you want to make the evacuation route smoke free, it will not help.
But it would help in
it will help. But then it will help on keeping the fire under control. It will reduce the pressure buildup. But that's the same for a residential sprinkler system.
So you could compare it.
Yeah.
Okay. Okay, and Ruud?
Yeah, I agree completely with Pieter. A water mist system can work correctly, but it matters what you want to achieve. With a sofa on fire, survivability in the fire room, it's just not a guarantee.
No.
Smoke propagation to the escape route, it's just not guaranteed. Smoke propagation limited to other apartments, well, it can work for quite some time. I don't think 90 minutes.
No.
We haven't tested it, but I think that just not that long, but it can really help to improve the available safe time on other apartments.
Yeah, so again, we need source and effect measures together to make it better.
It also differs really, if you have a sofa on fire, it's a really more severe fire. If you just have a little bin, then a water mist system just might put out the fire quite fast.
On its own.
Same with a sprinkler system. But with a sofa on fire, really intense fire, it's a bigger issue for extinguishing systems.
Yes. Okay. Okay. Thank you. I learned something else from your presentation. If there's a fire, they should not look at me because I think I know the building and I'm a male. So, but okay. So thank you very much for this discussion. And let's go to the final part of this webinar. Just stay here. I will finish up, and then we go to another part of the program. Yes. Okay. Thank you for watching at this webinar. Here at the screen is the program of the Fire Safety Week. Christophe already told you a bit about the program. Please have attention for the afternoon, where there is a roundtable discussion about carbon monoxide. And that leaves me with the final words. I think this webinar emphasizes the importance of increasing the fire safety for vulnerable community, improving escape time for people during a fire, and raise the awareness, which are all parts of the European Fire Safety Alliance action plan. So please look this up at our website. And in order to result in fire safety solutions, we should be more flexible and take into account changing construction methods, energy systems, housing types, evacuation strategies, changes in groups, vulnerable groups, but also take into account human behavior in case of fire. That being said, thank you all the speakers. Thank you, Ruud. Thank you, Pieter. Thank you, Margo. Thanks to the European Fire Safety Alliance for organizing, to the Netherlands Institute for Public Safety, and to our technical party, Nieuwenhuis, who made this possible, this webinar. And of course, to you, all the participants. This would not be able if you were watching all together. Enjoy the rest of the European Fire Safety Week and see you soon. Thanks.